So to find the A, B, and C on this one, we're going to multiply everything by the denominator. So I'm going to multiply x times x minus 1 squared. I'm going to multiply this, and I'm going to write out the x minus 1 twice on that one. You'll see why in a minute. Okay, so now we're going to cancel out the stuff that cancels. This x cancels with that x, so that leaves me with a times x minus 1 squared. This x minus 1 cancels with one of the x minus 1's, so I have b times x squared minus x. I'm going to go ahead and multiply this x by x minus 1, so I have that step done. This x minus 1 squared cancels with that x minus 1 squared and leaves plus cx. Because I multiplied both sides by the denominator, this denominator is going to cancel out, and I'm left with x squared plus 2x plus 7 on the left. Okay? Now, you need to multiply this stuff out in order to get to the next step. So x squared plus 2x plus 7 equals a times x squared minus 2x plus 1, and I can go ahead and multiply those through. So bx squared minus bx plus cx. Okay, I'm going to do one more step and then I'll see if you guys have questions. X squared plus 2x plus 7 is equal to ax squared minus 2ax plus a plus bx squared minus bx plus cx. Okay, does everybody believe me so far? Do you see where I got all those numbers?
Where'd you get the b squared or b
Times x squared minus x?
Yeah, I see b squared x.
Because the denominator is x times x minus 1 squared. So I wrote out x and x minus 1 and x minus 1.
Yeah.
It's only over x minus 1 to the first, so one of those cancels out. So I've got to multiply all this together. So I could have written bx times x minus 1, but I went ahead and multiplied those two together first and got x squared minus x and then multiplied it by b to give me bx squared minus bx. Does that make sense? Okay. Now start organizing your stuff. You have an x squared, you have a 2, and you have a 7. So underline everything with an x squared in it. So you only have those things. Okay? Then I put a squiggly line. If I don't have colored pencils, I put a squiggly line underneath the next thing. So 2x, so everything that has an x in it, an x to the first, gives me that. And then you can circle everything that doesn't have an x in it. So you've got a 7, and then you just have an a, so that's going to help us out in a moment. So because I have 3 different types, I'm going to have 3 different equations. I'm going to have an x squared equation, I'm going to have a 2x equation, and I'm going to have a 7 equation. So the x squared equation is going to be x squared equals ax squared plus bx squared. And my 2x equation is going to be 2x equals negative 2ax minus bx plus cx. And my 7 equation is just going to be 7 equals a. Now this is a really important step, and it's different than what you guys have done before. Do you see where those 3 equations came from? Okay, so now we're going to write them without the x's in them. Okay? If x squared, or this is really 1x squared, if 1x squared equals ax squared plus bx squared, then 1 must equal a plus b. So that's just a coincidence. Okay, Brighton asked about that a little bit ago. That happened to be in the equation before, but it's just a coincidence. Okay, this equation becomes 2 equals negative 2a minus b plus c. And then this stays the same. 7 equals a. So everybody see where all that comes from?
Yeah.
Okay, now this is nice. If 7 equals a, we know what a is.
So 1 equals 7 plus b.
exactly. So if I plug it into there, 1 equals 7 plus b. So that means -6 must equal b. And once I have those two, I can plug it into that one. So 2 equals -2 times 7 minus a -6 plus c. 2 is equal to -14 plus 6 plus c. So that's 16 equals 6 plus c. 10 equals c. So based on what we said at the beginning, that means that x squared plus 2x plus 7 over x times x minus 1 squared, that is equal to a, which there was 7, over x. Oh, you can't see me writing it. There we go. Plus b, so -6 over x minus 1, plus c, which is 10 over x minus 1 squared.